Alright, hello, my name is Brian, and I'm going to be going through Mastering Physics problem 12.63. A 45 kilogram, 5.3 meter long beam is supported but not attached to the two posts in the figure. A 25 kilogram boy starts walking along the beam. How close can he get to the right end of the beam without it falling over? And here's the figure, and it gives us the information that these two supports are 3 meters apart. So I'm going to start by drawing a diagram, a picture. And there's our boy. Okay, and I'm going to go ahead and draw the different forces that are acting on the object. So we know there's going to be a normal force here on the beam from the support. From the center of the beam, we're going to have the force of gravity acting on the beam by the earth. And then there's also another normal force here from the boy. So on the beam by the boy. And then you might think that there's going to be a normal force here on this second support. However, if the beam is perfectly balanced over this support, then there's going to be no normal force here. Okay, so we'll make our pivot point here. So from that we know that these two different forces are going to each have a torque, and then this force that's coming from the pivot point will have a torque of 0. So what do we know? We know the mass of the boy, 25 kilograms. We know the mass of the beam, 45 kilograms. The beam length, .3 meters, and we're going to need to know the radius from the pivot point to the different forces. So we'll label this one from the pivot point to gravity R1. So if this distance here, we were told it was 3 meters, and the total distance of the beam is 5.3 meters, so half of 5.3, .65. So the distance halfway, 2.65 meters. So all we have to do is subtract 3 minus 2.65 to get this distance here, 0.35 meters. So the other distance we need to know is R2, the distance from the pivot point to the boy. And that's what we're going to be trying to find, is R2. Because the question is asking us how close can you get to the right end of the beam without falling over. So to find that, we need to know R2. Since the beam isn't moving, we know the net torque is going to be 0. So means like the torque from gravity, I guess we'll call that torque gravity, it's moving counterclockwise, so it's positive. force of normal, or the torque of normal, that's going clockwise, so that's a negative. So the torque from gravity is going to be R1 times the force of gravity times the cosine of 90 degrees. And it's 90 degrees because the force is at a 90-degree angle from the beam. And then the torque from the normal is going to be R2, force normal, and that's also cosine 90 degrees because the angle of the force is 90 degrees from the beam. So we can add this to both sides of the equation, and we'll get R2 force normal. We know cosine of 90 is 1, so we can just leave that off. And then we're solving for R2. So we're going to divide both sides by the force normal. Force of gravity is the mass of the beam times g. And then this normal force here is going to be equal to the magnitude of the force of gravity on the buoy. So it'll be mass of the buoy times g. The g's will cancel out. So R2 equals R1 times the mass of the beam over the mass of the buoy. So we can input our values, 0.35 meters times 45 kilograms all over 25 kilograms. So 0.35 times 45 all over 25 equals 0.63. And for our units, the kilograms cancel, so you're left with meters, which makes sense because we're looking for a distance. Alright, so now we know R2. But we're looking for the distance to the end of the beam. So we'll take the total beam length, which is 5.3 meters, and we'll subtract the 3 meters from the left side of the pivot point minus R2. And we get 1.67 meters. Mastering Physics wants two significant figures, so our final answer is 1.7 meters. Okay, and for an assessment, we'll think about if this answer makes sense. So we know that if the total distance of the beam is 5.3 meters, we'll know that the distance to the right of the pivot point must be 2.3 meters. So our answer has to be less than that, because otherwise the buoy would just walk off the edge of the beam. We also know that the torque, the magnitudes of these two torques, are the the same, they're equal. And since the mass of the beam is much bigger than the mass of the boy, we know that the distance for R1 must be less than R2, which in this case R1 is 0.35 meters and R2 is 0.63 meters, so that makes sense. So this answer makes sense.